Welcome to the CrySP Speaker Series on privacy. It's our great pleasure to have Chelsea Komlo. Chelsea is an open source software developer. She works for, by day, HashiCorp, writing open source distributed scheduling software. She's a software engineer and a security engineer. And by night, she's a core developer for the Tor Project, working on a number of aspects, including porting parts of Tor into Rust, into the Rust programming language, which we seem to have a fan in. Great. And she will be talking to us about how privacy-enhancing technology research interfaces with deployed projects like Tor. So let's welcome Chelsea.
Cool. I'm going to migrate out of the light. Yeah, thank you so much for having me. I'm really excited to talk to you. There will be 10 minutes for questions at the end, but if you have a pressing question, feel free to shout it out. And so yeah, as Ian said, today we're going to be talking about where theory meets practice for privacy-enhancing technologies. And so really today it's very geared towards implementation, and essentially if you're interested in getting your research into projects like Tor. How can you work with those projects in order for that to actually transition to something that's deployed and being used? So yeah, just a little bit about me. I'm a software and security engineer. I work for HashiCorp. HashiCorp builds distributed systems for essentially cluster and data center management. So I work on a distributed scheduler. Before I worked for a company called ThoughtWorks. ThoughtWorks is a global consulting company. And there I worked around the world working with large enterprises. I also worked on an open source team working on the OTR v4 protocol, so on some of Ian's work. And I've worked with Tor for about 2.5 years. I work with the core network team and I go to all their meetings. And yeah, some of the last work that I did was essentially adding support for Rust as a first level language in Tor, which is an ongoing work. And if you'd like to talk about it after, please ask questions or we can talk after. And something I'm really proud of is I've worked in 5 countries and in 2 languages. So I've done consulting in Spanish, which was very hard. So yeah. And yeah, I just want to say thank you for CrySP for hosting us. So Matt Finkel here will also be giving a talk tomorrow on mobile and privacy, so please come to that. And I'm also thankful to the Tor team who provided feedback for this talk. So a lot of these ideas are things that I've directly experienced, but they also come from the Tor team. So I've gathered a lot of feedback from some of the core members there. So this was definitely a collaboration of several people. Okay, so I'm going to start out by saying something that's hopefully pretty obvious, and that's that privacy-enhancing technologies rely on the research community. We rely on the research community for a lot of things, but just a few things that are probably really obvious. We rely on the research community for identifying new vulnerabilities, creating new solutions to existing problems, and reviewing and verifying designs. So maybe something has been deployed in the wild, no one is really quite sure if it works or not, so the research community is extremely helpful for taking a look at what's there and helping it improve or working with us to deploy new things. Sorry, I just want to make sure. Yeah, and so in an ideal world, we know that the research community is super helpful. There's a lot that we can do with what's being discovered. And in an ideal world, there would be a symbiotic relationship between those who are doing research and those whose projects would benefit from that research. So ideally, this relationship would be mutually beneficial, and we'd work together really closely, and there would be ponies and rainbows, and everything would be great. Oh, sorry. I should also repeat the question. I think I want to make sure I understand the question, but it's not that the relationship should go only one way. It should go both ways, essentially. Okay. Yeah. So yeah. So essentially, hopefully the relationship does go both ways. At least I also believe that. So right. So this is an example of research going both ways. This comes from our own Ian Goldberg and several other people, if they're here. I'm not quite sure, but I know Ian. So yeah, so this is an example of research and practice going both ways. And This is a paper that Ian wrote. This was incorporated into Tor, into what's called the Tor protocol. So this paper identified a vulnerability in the prior authenticated key exchange that was used in Tor called TAP, and identified that vulnerability and essentially proposed a new authenticated key exchange, which is used in Tor today. So I just wanted to highlight a positive example of something that's used and deployed to the full Tor network. Okay, so with that said, we would like this symbiotic relationship that would go both ways. In reality, what we have found is that there are a lot of good ideas, but it can be difficult to incorporate them. And what we've found is that integrating new research findings isn't always seamless or predictable. And we've also found that good ideas get lost or forgotten about. And so in this talk, I really want to focus on this issue where there are good ideas and integrating them is difficult and maybe doesn't necessarily happen and things just sort of get shelved and forgotten about. So yeah, that's exactly what I just said. But in this talk, we're going to look at why good ideas fail to be incorporated into privacy-enhancing technologies. We're going to be using a hypothetical case study to examine these issues. So we'll have sort of a straw man to poke at and to sort of examine these issues against a real example. And then at the end, we'll look at another positive case study and some overall takeaways. Right, and one thing I just wanted to specify is that today we'll be focusing mainly or entirely on open source software and privacy enhancing technologies. There are cases of privacy enhancing technologies that could be closed source, but today we'll focus specifically on open source software. Okay, so I'm going to introduce a very contrived case study. This is not real. There are problems with this case study, but I wanted all of us to have a same frame of reference so that when we go through and we talk about these issues, we'll have something to sort of point to as we're going throughout this talk. So please note that there are some problems and feel free to point out the problems, but this is not sort of a real study that I'm pointing to. And mainly I didn't want to sort of poke at any one particular person's research. I thought it was just good to sort of pick something and we can talk about it. So I didn't want to call out any one person's research for not having been actually transitioned to practice. So this very contrived case study is that Tor should migrate to use a mixnet protocol. So this is sort of the research, proposed solution. So in Tor, Tor uses a concept called onion routing. And onion routing is a connection-based protocol which hides the client's IP address via a multi-hop path between a source and destination. So that is what is currently in use in Tor today. And this sort of proposed research solution is for Tor to use something called mixnet protocol A. And mixnet protocol A is a connectionless protocol that uses permutations at each stage along a given path between a source and destination. So what is currently in use is onion routing, and the proposed solution is to move to mixnet protocol A.
But what's the problem? Is it security or is it performance?
Yeah, we'll get there. Thank you for asking, for clarifying. So, okay, we're gonna talk about why you might want to do something like this. So onion routing essentially protects against local adversaries. So if you are in Australia and you want to visit a site, but you don't want the Australian government to know that you are going to visit a site, you would use something like Tor, which would route your request throughout the Tor network, and essentially it would route it to some other countries and it would exit in, say, Belgium, for example. And so the Australian government is not able to actually see where your request is going to. With that said, however, onion routing does not protect against a global network adversary. So what this means is that the adversary can have a complete view of the network. And so, for example, in a place like China where there's a firewall, we can't actually just deploy a miniature version of Tor in China because China would be able to see essentially this sort of sub-network within China, and anonymity would be broken. And this is something that Tor does not protect against. And so a mixed network, essentially at each hop, introduces uncertainty by mixing at each hop. So a router in a mixnet might take in 50 packets, and then it would use, it can use a lot of different ways to do this mixing, but in this very contrived example, it would use something like latency. So it would receive a bunch of packets, and then it would use random batching to send those packets out. So for someone who is watching the network, it introduces uncertainty because it's harder to correlate a packet that comes in and a packet that goes out. And whereas something like the Tor network, if a connection comes in, the network, as quickly as possible, will send that packet out. So it's easier to do end-to-end timing attacks. So that's essentially the difference between something like onion routing and mixed nets, where mixnet would protect against that sort of global adversary that might do something like end-to-end timing attacks. Okay, so that is our very contrived case study. We'll be referring to that throughout this talk. With that said, we're now going to talk about why good ideas fail to be incorporated. And this is just a short list. It's incomplete. So feel free to offer other ideas or also things maybe from the research community, what might be difficult working with development teams at the end. But this is something we came up with. So the ideas that we'll be talking about in particular are challenges with incompatible design, inconclusive analysis, insufficient information and reproducibility, having subpar implementations. So if we're past a patch, maybe there's something that's really difficult with it that we can't merge, and also people difficulties. So we know that software is also about people, so sort of addressing the people component in all of this. Okay, so first we'll be talking about incompatible design. So why might something that has been proposed to us not be incorporated? And for this, we'll be focusing on incompatible design. So referring back to our case study, Tor should move to a mixnet protocol. So we've said that our research study showed that the security properties of Tor would improve by moving to use this mixnet protocol A. And we've said that doing so would provide resistance to this global network adversary. So we have our problem and we have our solution. Digging into this a little bit more and sort of analyzing this solution, we know that certain properties would improve, but they would have to be weighed against some of the trade-offs. So we were actually discussing this before, and Tor itself is about 100,000 lines of C. And we estimated that if Tor were to move to a mixnet protocol, probably maybe a fifth to two-fifths of Tor would need to be rewritten for this sort of protocol change to happen. And so this sort of protocol change isn't impossible, but it is fundamentally different than what Tor does right now, and it is a huge endeavor and possibly even worth like rewriting entire parts of the code base. So what I want to say with incompatible design is not that it can't be done, but it is so radically different than what the project is doing right now that there's a huge cost to it. So resources required for the engineering effort to make this sort of transition is enormous, and it would probably, just off the top of my head, it would probably take someone maybe a year to 2 years, if not more. It would be quite a lot. And so really, we would have to take a look at this and take a look at everything else that the team is needing to do and weigh, is this an effort that this project would be able to do? Another thing that's really important to consider is, could this engineering effort be completed with zero network downtime? So we can't just turn off the network and say, like, okay, let's do a network upgrade right now. We support users around the world, and not providing sort of network connectivity is something that we just can't do. So taking a look at some of these different protocols, we really have to think about how can we deploy this in a way that we continue to provide service for all of our users. So yeah, just some examples of what it means to have incompatible design. It might be incompatible with the current or future architecture of the project. It might be incompatible with the project's goals or purpose. So Tor aims to be a low latency network. So you can do things like stream video while using Tor. So adding something like a mixnet would induce latency into the network. And also incompatible with day-to-day operations. So for example, can we roll a change like this out while still providing service to the millions of people around the world that use Tor? Okay, so how might we improve a situation like this? So one thing that might be useful if you do want to advocate for this big of a change to a project is to potentially advise incremental changes in something called a minimal viable product. So are there things that the project can do, taking smaller steps to go to this larger design? This is actually really hard. So I was trying to think about this, and I was trying to think about like, how would you incrementally move from something like onion routing to a mixnet? It was challenging for me to think about how that could actually be done. So I'm not saying that doing something like this is easy. It's potentially extremely useful for projects that aim to provide continuous service to users. Another way to improve incompatible design is to recommend an iterative solution. So the goal of this is to not have a patch that is named switch Tor to use mixnets instead of onion routing. Ideally, we would merge in changes that are smaller, maybe introduce things into the network, a subset of features at a time. So really trying to think about how do you take an iterative approach to actually merging in this type of big change. And then another thing to improve is try to avoid breaking upgrades or downgrades if possible. So if you're doing something like deploying to a full network, what would a graceful downgrade path potentially look like? Okay, so that's looking at some kind of aspects with incompatible design. Now we'll look at problems with inconclusive analysis. Okay, so we have been talking about moving Tor to a mixnet protocol. We know that adding latency and essentially batching between sending and receiving packets would prevent end-to-end timing attacks, or it would help prevent end-to-end timing attacks, not completely prevent. So as we've seen, essentially with a mixnet, every single relay would add random batching and latency as you're sending packets throughout the network. Okay, so let's dig into this in terms of analysis. So one question that's really important to answer is, how does this proposed design impact other engineering trade-offs? And what do I mean by other engineering trade-offs? I'm very sorry for this slide. This is a long list of things. Don't worry, hopefully after this talk, we'll actually be publishing a checklist that researchers can use for this type of cross-analysis in proposing changes to Tor. So these are some of the things we thought of. We're going to be going through this and actually publishing this as something of, when you want to propose changes to Tor, make sure your analysis covers these cases. So some of these cases might be, how does this impact security or Tor's threat model? So by adding something like a mixnet, you are able to help prevent some kind of end-to-end timing attacks, but does this introduce other security issues that weren't an issue for Tor before? Another thing is performance. So per every single relay and for the entire network. So essentially what kind of performance impact would this have for the network? Scalability. Does this scheme scale to thousands of relays and for millions of users? Also for user experience. So users should be able to do everything from downloading large files to streaming videos. So how would this impact the user experience of using Tor? Network load. So does rolling out something like a mixnet increase network load? Also, engineering complexity is something that's really important to think about. So complexity is, I've heard said, complexity is the enemy of security. So if we introduce something that's extremely complex, that's hard to maintain, that can be hard for engineers to keep straight, what kind of impact does this have on the team overall? Also, protocol complexity is something to keep in mind, and that is congruent with engineering complexity. Failure cases. So for schemes that are introduced to Tor, nodes need to be able to intermittently fail. So does this scheme stand up to nodes dying and coming back? Corner cases. We always discover corner cases every single time we integrate new changes into these types of projects. So what kind of corner cases should be explored? Extreme cases. So how does this hold up against something like a DDoS attack? And finally, one that's extremely important is compatibility with upgrades, downgrades, and multi-version deployments. So for something like a large network, not everyone is going to upgrade at the same time. So how does this work with a bunch of different versions running on this network? So very long list, lots to think about. Okay, and sort of like we talked about before, essentially when proposing changes to Tor, one thing we have to think about is how to continue supporting its current uses. So thousands of relays, millions of users, and wide application usage. So how might you improve upon something like this? How might you be able to add further analysis before proposing changes? This may have varying mileage, but I think one thing, especially with user experience, is comparing trade-offs to industry standards. So there is some research out there about how user experience degrades with increased latency. So for something like Tor that's potentially being used in conjunction with other browsers, how does user experience change? And are users unwilling to use this product and instead switch to something that isn't privacy preserving just because it's easier and less of a hassle to use? And another way that we talked about how to improve is to consider trade-offs holistically. So by proposing this one type of change, does this outweigh any of the other trade-offs that we talked about? Yeah. So the question is, by moving to something like a mixed protocol, shouldn't this be transparent to the end user who's just using Tor browser? And because the mixed network is essentially this network layer, that the end user shouldn't be aware that the network is now using something like a mixnet protocol. In theory, that should be true. However, if the mixnet protocol induces latency, then it would be apparent to the end user. So Tor is a low latency network, and if you were to add something that adds latency at every hop, then that would be something that would impact the end user. Good, yeah, that is a good clarification though. Okay, yeah, so essentially with something like inconclusive analysis, one thing that we talked about as a team is that when new research comes to the team, there's often a cognitive load. So the cognitive load essentially being that, first of all, reading and understanding this type of research, but then also thinking of all these other sort of engineering trade-offs and trying to understand where it fits amongst this long list. And so as much as researchers can, trying to lower the cognitive load so that a lot of this analysis is done and we can look at it. We're not the experts. I mean, a lot of people are experts, but you are the expert in your research, and sort of helping us understand where it fits would definitely be beneficial. Okay, so now we're going to be talking about this next trade-off. So this is insufficient information reproducibility. This is a joke. So essentially, the joke is how to draw an owl. You draw 2 circles, and then you draw the rest of the owl. It's a joke about, essentially, there's no middle steps to say how to get to drawing the actual owl. Or 2 ovals. Is there a way that you can roll out changes to only a subset of users? For things that don't break something like anonymity, you could. So for example, with the Rust work that we did, you can voluntarily enable Rust, and that should work the same and act the same. I think it depends on what the feature is. Yeah. Okay, so going back to our case study, Tor should move to a mixnet protocol. Yeah, we want to add latency between sending and receiving packets to help prevent end-to-end timing attacks. This latency can be randomly chosen, but should be influenced by certain properties depending on network load. And these results were validated on a test network of 10 nodes. Cool. Okay, so there's some problems here. So yeah, so there's some general issues that would make reproducing this difficult. So obviously, not all the parameters are published. For example, how would you calculate the mixing latency? It's not clear what the upper and lower bands would be for latency. So are there certain sort of endpoints that you really shouldn't cross when choosing these parameters? And fundamentally, how would this experiment turn out differently when running on a large network?
Upper lower bound or upper lower band?
I think I meant to write bounds, but
Okay.
either one.
I'm wondering what a
Yeah.
band was.
Yeah, sorry. Yeah. Just to repeat, upper lower bounds or bands, and it should be bounds. Right, so just some examples of what insufficient information or reproducibility might mean. Just unable to independently reproduce results is an issue if you're trying to add this research into your project. Poor documentation and a lack of explicitly defined assumptions can also be an issue. And a sort of overall sort of insufficient research rigor. And this depends on the experiment that's being done, but having small data sets and insufficiently controlled experiments can be an issue.
And what's your, on the first point, what's your comment to researchers?
Being unable to independently reproduce results.
Yeah. It's bad, it's good,
Yeah, we would like to independently reproduce results. So having sufficient information in order to do so is important. So having less guesswork as we're trying to reproduce this.
I think in computing that's a huge problem.
Mm-hmm. Okay, so how might we improve something like this? One thing we've talked about is having a peer review to assess how independently reproducible are these results. So having someone else come along and say, on a scale, how could someone else read this paper and reproduce what this person suggested? Having code samples is really important, and test vectors, and really everything from library dependencies and operating systems the tests were performed on. So maybe you're using a library that works one way on one operating system and has bugs on another operating system. So really sort of all of the factors that go into your experiments. One thing that probably seems really simple, but we've run into before is making sure the implementation code doesn't go away even a few years later. So someone might be looking at implementing something you've written about 5 or 10 years later. I mean, it really depends. So making sure that things don't go away after you've done the research. Okay, so not much time left, but we're going to talk now about subpar implementations. So I think it works differently at different universities. I know some universities have people who will go and actually full-time work on implementing stuff for projects. I know sometimes researchers pass over their own research implementations. We'll talk overall essentially about what it means to merge code into projects. Okay, so Tor should move to mixnet protocol. Our paper has had successful results, and this patch is ready to be integrated into Tor. The patch is 10,000 lines of code, and it doesn't have any tests. So as a code maintainer, this is strikes fear into our hearts. So one thing we have to think about is when we're getting these large patches is a lot of different questions, and it's extremely difficult with a patch that's that size. How do you sufficiently review this type of patch? How do we know that the patch is doing what is expected? So maybe in your paper you've written about a subset of cases, maybe your patch handles more cases, and it's hard to know, does this actually handle, what cases does this code handle? How do we know that the patch performs at scale? So maybe the patch was tested on 50 nodes, but what happens when we deploy it to something that has 7,000 nodes? And one thing that seems pretty obvious, but we've actually had a lot of issues with, is how to reconcile the patch with more recent changes to the code base. So maybe you forked Tor a year ago and you did all of your work and now the patch is ready to go. Since then, a lot of work has been done on Tor, and reconciling those patches has essentially left us saying this code is unmergeable.
This is source level patch or boundary patch?
The question is this for the source code?
Is it source code or?
Yeah, so the question is this patch for the source code? And yes, it would be.
Okay.
Yeah, so essentially you've done your research and you are proposing this to be integrated, and the patch is for the actual project. Yeah, so just some examples of patches that are extremely difficult to merge. So large blobs of code, code drift, so having the source code get out of date with where the project is now. Untested, so tested code should make a lot of maintainers extremely happy. So untested code is really hard to deal with. Undocumented code is also extremely hard. Interwoven and cyclic dependencies, so if someone needs to go and refactor your code or make changes to this after, having code that's well isolated will make a lot of maintainers very happy. And fragile code, so maybe your code is doing things like parsing. When you're integrating it into a larger project, making sure that it's sort of robust and handles errors and isn't very fragile or brittle. Okay, so how do we talk about to improve some of these implementations? Yeah, so write tests. If you are writing code that is going to be integrated into a project, it's extremely useful. It will serve to both document your code and prove that your code functions as everyone expects. And Tor actually has a lot of tests. It's something that it does extremely well. If you ever try to submit a patch to Tor, people will ask you to have your code tested. So this is our build, and it runs against a bunch of operating systems and tests everything from Rust to not Rust and kind of everything in between.
So what kinds of tests would you do in this sample situation where you're trying to switch to a mixnet? Just test that it doesn't crash? Right? Do the tests include set up a Tor network and check that it has the behavior you want? What is the scope of these tests?
Kind of everything in between. So Tor does, and a lot of projects do sort of multi-level testing. So you would have something like unit tests. So at your function level, every single function should have tests to make sure the inputs produce the correct outputs. Tor also has something that's called integration or feature tests. The project is actually called Chutney, and it does that sort of end-to-end testing as well. There's also Shadow, which I don't have as much experience with, but Shadow is what runs simulations to make sure that the actual performance is what you would think it would be. So I would say testing at all of those levels is important.
Is there like a test framework in Tor where I can say run, like when you type make test, it runs Shadow?
There's not that in Tor. It is not hard to set up, as I understand.
Right. You can run Shadow separately, but
Yeah.
it's not integrated into Tor's test framework.
Yeah, my understanding is not.
But Chutney is?
Chutney will run along with make test in Tor. Yeah, so yeah, if you are integrating code into Tor, you will be expected to have unit tests, probably for something like this mixnet example, Chutney tests, and then along with your paper, you probably run simulations in Shadow.
you enunciated I'll call it a premise, that it's good to have code. Maybe it's better not to have the code.
So the question is it better to just have the paper and publish the paper?
So
Yeah.
just to kind of flesh out that example, I publish the paper on some good venue. You sort of read it and it sort of has some intuitive appeal. You think, yeah, this can work. That's the end of the researcher's contribution. After that, the Tor folks, you do some meaningful, I'll call them meaningful, like real worldish kind of little tests to see if this can work. And that's it. And you don't have to deal with 10,000 lines of crappy code.
I think that goes to, okay, so the question is, should the researcher just publish the paper and then the developers essentially come along, read said paper, and then do the implementation? I think there's a spectrum along how probable and useful doing something like that would be. So that definitely has happened. It's also happened that research teams have people who implement the code and it gets merged in. There's also been research teams who implement the code and it doesn't get merged in for these reasons. I don't think I can be prescriptive and say which one would be better. I think we would be happy if there were great ideas that came along with great patches. As many open source, very strapped projects would be. People can also read the papers and do the code as well. I wouldn't say that one is necessarily better than the other. I will recognize that these projects are extremely strapped and there's a lot of good ideas. So I guess it depends on where the resources are and able to do this implementation. Okay, yeah, so anyway, this is specifically for people who are doing implementations, if you're interested. If you're not, then that's okay. But yeah, so anyway, one thing that the team mentioned that is extremely useful, and it sounds very simple, is to meet with the team along the way. So having good relationships with the project that you're doing work with is important. And then, yeah, if you are writing code that you hope to get merged in, writing something that won't make someone sad to maintain for the next 5 to 10 years is really useful. And then this should be hopefully fairly obvious, but if you want to merge code into a project, it should be really simple, but it continuously rebase your branch to the master branch of the project so that it's easy and there's not this big diff that people have to fight through at the end. Okay, so this is the last topic that we'll be talking about today. And really this sort of acknowledges that software projects are made up of people and researchers are people. So just talking through some of the people difficulties that can go along with getting research merged in. Right, so this sort of is what you were just talking about. So the research is done, the paper is published, and researchers are moving on. Unfortunately, or fortunately, there's this sort of publish or perish model. Maybe you don't have a lot of time after to see the publication through to the end, and maybe you are continuously to go on to the next topic. So, so after research is done, there is a lot more that needs to happen. So you are the expert in your research. One thing that can be extremely helpful is onboarding the team so that they understand the domain and the proposed solution. People can go and read the paper. Reaching out and talking to people is also really useful. So we do have several researchers that come to Tor meetings and work with Tor developers, and that's something that has proved useful over the years. And one thing that helps with that is ensuring that unexpected issues are resolved. So maybe they read the paper and the solution has been tested on 5 nodes and we go to scale to 5,000 nodes. There might be unexpected consequences, and being able to talk to people is really helpful. Yeah, so something that might be difficult within the team is just a lack of domain knowledge. So it can make doing this sort of analysis difficult, and it can also be difficult to prioritize the work due to that knowledge gap. And then, yeah, not being able to reach out and sort of talk to people means that concerns or questions aren't asked, and the work can just sort of disappear. One thing that we've talked about that can be improved is having a champion within the project for this particular idea. So maybe you meet with one person on the team and they really understand your work, they're excited about it, and they can sort of be the champion to make sure that this work is shepherded through to the end. One thing that we do in software engineering is something called pairing. So pairing is where you work with someone for maybe several hours on code implementation or on a design. So that is one very effective way to do knowledge transfer. So maybe you offer to pair with some of the developers on that team during part of the implementation or some of the analysis phase to ensure that questions and remaining work are taken care of. Okay, yes.
Well, the thing is, when you started with the people thing, pointing out the problem that the academics who are under the publisher pairs thing, there's no incentive to do all the stuff that you told us to do in order to see it through. So the solution is you're publishing in the wrong domain, write a case study of how it was ported and seek to publish it in the software engineering domain. So now you get a publication out of the experience of porting it to an actual practice. Okay, so there's your incentive.
Okay, great. Yeah, so I'll repeat that.
Okay,
So,
I mean, of course,
yeah.
I can see that the security community isn't interested, but the software engineering community, where we're dealing with people problems and precisely this thing, would be interested in seeing a description of how you overcame these issues. So everybody submit to our area.
Yeah, there we go. Yeah, so essentially, yeah, within the, how do you create incentives for actually porting these type of solutions to real projects? And that is write a paper about what it means to take the solution and port it to a project. And that is interesting to people. And that is certainly interesting to us. Okay, so I just want to talk really quickly about a positive example that worked well within Tor quite recently. So the work was called KIST. It's kernel-informed socket transport. And essentially what this paper did is it used feedback from kernel congestion to inform how much data to transmit. It essentially changed it changed how Tor does transmission of circuit data. Before, Tor would essentially look at every single socket and choose a circuit on that socket to send data. This improved performance by choosing the highest priority circuit and then using the kernel to inform how much data to send on that socket. And what worked really well with KIST, this is in use in Tor today. So KIST had a person that was working really closely with us. He attended all of our meetings. He attended all of our IRC meetings. So he worked really closely with us in order to get this implemented. There were several rounds of iteration, both for code review and for performance. So I know that the first iteration wasn't enough. They did a lot of testing and sort of working with us to make sure that it was where it was at. We wanted it to be. And one thing that may or may not be difficult is that they had sufficient funding or man hours for the implementation and for code review. So this was a many months process. It didn't happen immediately.
So, quick question, the incentive for this person, what was it? Was it personal or?
I believe this research group has someone that does implementation work. So they did have those kind of resources. Okay, so really quickly, I just wanted to talk about some overall takeaways from this, and then we can move on to questions. Yeah. So some of the takeaways for research. One thing that's extremely helpful is holistic and rigorous analysis. So sort of not just taking a look at a few trade-offs, but really looking at the project as a whole and making sure that thorough analysis has been done. And then to go along with that, consideration for engineering trade-offs. So even considering things like added complexity into the cost benefit of implementing some of these solutions. And finally, hopefully having sufficient information and ease of reproducibility. So if you are just publishing a paper and not actually interested in doing the implementation, making sure that there's actually sufficient data out there that we can come along later and reproduce your work. And then just some quick takeaways for the implementation. Maintainable code will make a lot of project maintainers very happy. Sufficient documentation is extremely useful. And then knowledge transfer for project maintainers. So are you actually going to the meetings, meeting with the people? Do they have a relationship with you? Can they write you if they have problems? These kinds of things. And that's all. Thank you very much. Yeah, so the question is, at what stage should someone get in touch with the development team during this research process? I would say probably as soon as you start thinking about ideas. I think it's useful just to go and do even early validation. So you might be thinking of an idea, you've read a lot in the literature, maybe sit down and have a conversation and say like, hey, I'm starting to look at this. I mean, yeah, Ian probably has some thoughts on this too, but I would say like people, a lot of really good projects are happy to talk with you about their problems. So. Go ahead.
So I'm going to disagree slightly.
Okay, yes, please. This comes from the implementation side, so this is the research opinion.
So there are a lot of ideas. You don't want to be contacted about every idea a researcher has.
That is true.
Right?
Yeah.
You want it to be at least bubble up past at least to the, yes, this is a good idea. We are going to write a paper about this.
That is true.
Right?
Yes.
So you want at least some kind of high-pass filter.
Yes, that is true. Yeah, so in the Tor channel, we do have a lot of people that sort of pop up that say, we want to help Tor, and that's great. There is a cognitive load to onboarding new people. It takes a lot of effort for the development team. So trying to come to the project with something in mind, having done some sort of analysis or work beforehand, is helpful so that people have something to work with by the time you get there. Just because there are a lot of people who want to help and don't really have a direction, and so it tends to be, not that people don't want to not help, but the more you can sort of have your foundation and say, I'm interested in this, and have that base, that would be useful.
Maybe a suggestion.
Sure.
I'm just wondering if it's possible that the articles that you write are actually a README on a GitHub or GitLab repository where you have code, your data, so all of a sudden it's all reproducible. And for example, you take a Tor project or any project, right? You have an idea, you fork it, you do a little changes, you start to think about it, all of a sudden you have something concrete to talk with the guys who do actually implementation. So maybe like, can we stop thinking about the paper as like you used to do at journals 30 years ago, and more think of a paper as a README on a actual work on GitHub or
Yeah.
I think you have to have both.
yeah. At the end you have a pretty printing, because otherwise you read the pages and you think, is the only code that person had to go through was latex? Where can I show that this, wow, this magic? Nice. Or implementation. Sometimes like I have an idea, I do implementation, somebody comes and looks at the changes that were done to real code. And the real engineer seeing the changes in his code, he's like, oh, actually that thing would be better done in this way, then the results would improve. All of a sudden there's this communication.
And that's the CrySP students know. We like releasing software, right? Our CrySP software page has a lot of student projects.
Of working code.
Definitely graduate.
Yeah. Yeah. I think, I mean, I wouldn't say like if you just do grad work and then move on, that's totally fine. I think as long as there's sufficient sort of ways for somebody to go back and look at that and turn it into production code as well, that's really useful. So that's where things like tests or test vectors are really helpful.
I think all of our contributions that ended up merged into Tor, we provided code, but then the Tor team rewrote the code, and that is what we would expect to happen.
Okay.
Right? But we provided working code, maybe not beautiful code, and then the Tor team rewrote it. Right?
Yeah.
For all of the ones I can think of, that's what happened, including Tor.
So did you get lucky? I mean, is that what normally happened? Or did you get lucky and they went expedition for your work?
Did we get lucky?
Well, no, I mean, the point is, from what she was saying, I get the impression that they get a lot of stuff that they just say, it's too much work for us to do. But you described the situation when you sent them stuff, and there was work to do, and they nevertheless did it. So did you get lucky, and they decided to do more for you than for others?
Well, I like to think that we send them awesome ideas. But to be honest, we have produced many, many ideas of which only a handful have actually been merged into Tor, right? Only some of our things we've moved forward.
Yeah, but I mean, you and your students are also extremely active in coming to Tor meetings as well. So I would say that, I mean, there is quite a lot of communication.
Yeah, we are not random people on the internet sending code.
Yeah. So whatever does come is extremely well informed, and I think I'm not saying that like Tor developers won't rewrite code or do production implementations. They will. I think that there is a spectrum between writing a paper and doing the implementation, or Tor developers doing the implementation, to other people working on it and working with us. So I think it does depend. So.
Any other questions?
Yeah, please.
So there's this strange combination here for me between like down to earth and sort of high level. But let's pick an example of a down to earth thing that wasn't mentioned. Maybe it's not an issue. Choice of programming language, which might be an issue if I start a research project. I don't even think I'm going to contribute to a certain project, a real open source project. I might choose Java or something. But then I later find out, oh, it's brilliantly applicable to this, but unfortunately it's a Haskell shop.
Yeah.
So is there a reason that you can include that, for example, as a concrete example, choice of programming language in the context of Tor? Is that a problematic issue?
Well, I mean, Tor supports C and Rust for its main code base right now. So, I mean, something like Java wouldn't be an option if it were to be part of the core code base.
So if somebody send you 10,000 lines of Java,
yeah, I mean, I think choice of programming language is very dependent on the project that you're working with and the problem you're trying to solve. So if you're just doing a standalone project, then it probably is whatever you want to write along with the problem you're trying to solve. If you want something to be merged into an actual project, then I think it's relative to what they're able to support. So, So again, that comes with communication with the team. So, yeah, if you all have feedback about this afterwards, please do let me know. We are hoping to take some of these guidelines and turn it into a blog post for researchers who are interested in working on Tor. So feel free to approach me after, or I can give email, or Ian has my email address as well.
Okay, that's fine.
Thank you.